All right, welcome to the Introduction to Linear Equations video, okay? So you guys know my style. Let's just dive on in, okay? Let's not waste any time. Okay, so it's an introduction to linear equations. That's your key word there. Linear equations. So ultimately, what does this word linear mean? Well, linear just means a line, okay? So basically these are equations that equate to lines, okay? Now, equations. Why is it an equation? Ultimately because it has an equal sign. Whenever something has an equal sign, it's an equation. If it does not have an equal sign, for instance, let's just say it was just right there like x minus 6, that's a variable expression, which I talked about in my last video. Okay, so linear equations, what do they look like? Well, they look like this guy, these guys right here. Okay, the easiest way to identify it is it's just going to have a single variable, and it's just going to be that variable, meaning it's just going to have an x. Like these are all x's. I guess I should have mixed it up, but just x's or just a y, etc. Nothing else with it, like no x squareds, no x cubes, no fractions with an x in the denominator, etc. And I have examples of those right here. But basically, these right here are linear equations. This is what they look like, okay? And the more you see them, you'll just start to identify that these are lines, okay? So these, boom, those are linear equations. Now, these are not linear equations. Why? In your first example here, it's because we have an x squared here, okay? You see, if there was no x squared, and we just had the negative 4x plus 2 equals 0, then it would be linear. But, boom, this x squared messes it up. So this is not a linear equation. How about this guy here? It's not because it has an n cubed and an n squared. I mean, it's just all jacked up. That's definitely not a linear equation. And now this one here, if there was no bottom here, it would be a linear equation. But since we have a y here in the denominator, this is no longer a linear equation, okay? These are not linear equations. These are linear equations, okay? And that's just the start. We're actually going to have to use these guys and, we're going to learn how to solve them, manipulate them, and ultimately do whatever we want with them. Okay, so with that being said, the first thing we got to start off with, see, I got my little notes. Alright, so the very first problem says this. Is x equals 7 a solution to 5x minus 9 equals 26. So is x equals 7 a solution to this linear equation, right? So how do we do that? Well, what you do is you basically start off by rewriting that. So we'll just put it over here. 5x minus 9 equals 26. So what you're doing is you're just going to take x here, which is 7, and plug it in. So we have 5 times 7 minus 9 equals 26. Now, it's very important when you plug a value in for a variable, make sure you put parentheses around it, okay? It's going to keep you out of a lot of trouble. Okay, so what's 5 times 7? So now you just work the problem down. 5 times 7 is, right, 35 minus 9 equals 26. We just carry this guy along. Now what is 35 minus 9? Is 26. So we have 26 equals 26. So once you get down to the end here, you have to ask yourself, does this make sense? Is this a true statement? Does 26 indeed equal 26? Yes, it does. Boom, so you just put a little check mark. So you would write yes, x equals 7 is a solution to this equation, okay? So this is what it looks like when it is a solution. Let's see what it looks like when it's not a solution. All right, so is a equals 8 a solution to 3 minus 2a equals a plus 3a minus 11. All right, so we got a bigger guy here. So again, just rewrite this guy somewhere over here. So we have 3 minus 2a equals a plus 3a minus 11. So you see we got all kinds of a's in here. 1, 2, 3. We have 3 different spots of this variable a here. So what I teach my students is wherever there's that a, just open up a parenthesis. So you're going to have 3 minus 2, open up a parenthesis where that a is, equals parenthesis, plus 3 times a parenthesis, minus 11. So all you did was wherever there was an a, you just opened up a little, basically a little pocket there. Because now it's very simple, because you know a equals 8, you just plot that guy into all those parentheses, and you're good to go, okay? So now we just got to work this guy down until we get some numbers here. So, negative 2 times 8 is negative 16, equals, we have 8 plus 3 times 8 is 24, minus 11, okay? Now we can just start combining these guys. 3 minus 16 is going to be a negative 13 equals, okay, now we got to do this guy. 8 plus 24 is going to be 32, and then we got minus 11 here. So we got negative 13 equals 32 minus 11 is going to be 21. 21. Now, is this statement here true? Does negative 13 equal 21? Well, it doesn't even make any sense, okay? So when you get like opposite numbers here, like something on the left and something on the right that are completely different, the answer is no, okay? A equals 8 is not a solution to this guy here, okay? So whenever you get something that's just nonsense, it's just, no, it doesn't work. Wrong, okay? So hopefully that makes sense. All right. Now, we gotta learn a property, okay? This is, I'll do it in red. It's the multiplication property of equality, okay? So I'm not gonna write that down, but put that in your notes. It's the multiplication property of equality, okay? And it just looks like this. If A equals B, then N times A equals N times B, okay? So I know a lot of students can get mixed up when we have a lot of like letters and stuff involved, but let me explain, okay? A and B are just, you know, they can be anything. They can be equations, they can be statements, they can be numbers, they can be really anything. All it's saying is if you have something on the left equaling something on the right, then you can multiply both sides by anything you want, as long as you do it on both sides. So n is just a number, that's why we use n for number. If n was 5, okay, it would basically, as long as you multiply a 5 on the left and you multiply a 5 on the right side, then the equation's okay. Okay? And again, that's the multiplication property of equality. Okay? Alright. So I'll leave that up there for a little bit, and then let's do some problems. And you'll see, like, if this is confusing at all, it's going to clear up right now. Alright. So next example, we have x over 7 equals 2. And the directions are solve. Okay? So when it says solve, ultimately you're solving for the variable. So in this case, x. So solve for x. So how we do that is when you have a number here on the bottom, you just have to multiply both sides. Try to get some color coding here. Multiply both sides by that number. So 7, and then on this side as well. And this is what this is saying. This is like, this x over 7 is like your a, equals, this 2 is like your b, okay? And then all you're doing is you're multiplying both sides by something, by 7, okay? But if you do it on the left, you have to do it on the right, okay? Now, what happens with that is those 7s here cross out, because this is really like 7 over 1, okay? You can, any number, if it's just that number, it can always be divided by 1, always. It's just a property. So, since it's divided by 1 here, you can do what's called cross multiplication, okay? Which basically, you can just kill the diagonals if they match like that, okay? So, and that's very nice for us because now on this side, all we're left with is x. X equals 2 times 7 is 14. And you're done. That's your answer. X is 14. So what this is saying is for this statement to be true, x over 7 equaling 2, x has to be 14. And you can check your answer. Now, you should check your answer on every single problem. I'm not going to do that here because the video will get very long, but I'm going to show you how to do it, and it's the same process in every problem. So, you have x over 7 equals 2. This was the original problem, okay? So, x we found is 14, so just plug that guy in. 14 over 7 equals 2. Now, how many times can 7 go into 14? Exactly twice. So we have 2 equals 2. Boom, we're happy. This guy works. So you see, if you're taking a test and you're like, man, I'm not confident if my answer's right or not, just plug it back in and you'll know if you're right. Okay? So perfect. Okay, so I'm going to erase that property. It should be in your notes. Again, if you're not taking notes, pause this video and go get a notepad, alright? Alright, next problem. 5y equals 45, alright? So, ultimately what you're going to be doing here is, okay, you see this 5 and this y here? When two things are like real close to each other, like buddies, okay, it's multiplication, okay? And the opposite of multiplication is division, okay? That being said, because what you're ultimately solving for is this y here. Because remember, the directions are still solved, okay? The directions are going to be solved for the rest of this video, okay? So now this box is so heavy it cannot move. So you're not going to do anything with that box. So what you have to do is you have to work around that box. And this 5 is in the way because you want to get this box all by itself. That being said, what you're going to do is you're going to divide both sides by 5 because what that's going to do is it's going to cross those 5s off here, leaving that box alone, okay? That being said, you have y equals, now you just do this, how many times does 5 go into 45? That's going to be 9, okay? And that's your answer. And then again, you can go and check it, and we'll do this one as well. So we have, this is our check, so we have 5, y equals 45. Stick your answer into y, so you have 5, don't forget your parentheses, 9 equals 45. 5 times 9 is indeed 45. So 45 equals 45, we're good. We know that's our answer. We're on our way to getting 100% on our test, okay? So don't forget to check. All right, let's do another one. We have negative 4 n equals negative 12. So what are you going to do now? Again, when you're solving, you're always solving for the variable. So I like to put it in a box, and I say, okay, I cannot touch that box. That box is staying. How am I going to get that box by itself? And I'll give you a second. This is exactly like the last problem we just did, or last example. How do you think we're going to get n by itself? You're going to divide both sides, remember you have to do it to both sides, by a negative 4. Because what that's going to do is it's going to cross off each of those negative 4s, leaving you with just n on this side. So you have n equals, now negative divided by a negative is a positive number, so what I'm going to do is I'm just going to make little pluses out of those. And then you just do 12 divided by 4. And how many times does 4 go into 12? 4, 8, 12. 3 times. So n has to equal 3 in order for the original problem to make sense, okay? And again, check your answer. Alright, we got more of these. Alright, this one. Yeah, so this one is simple, but the reason I put it here is because a lot of times this will trip people up. They'll get a negative x here equals 8, and they're like, I don't know what to do. So what you do is, ultimately what you're doing is, if you want to get rid of a negative here, remember it's always like an invisible negative 1. So what you're going to do is you're going to multiply both sides by negative 1, and I'll show you why here. Because a negative 1 times a negative 1 is a positive 1, so you're just left with x on that side. 8 times negative 1 is negative 8, okay? And that's it. Now, let me show you a cheater method. It's not really a cheater method, it's just much quicker, okay? So, again, if you have something like this, let's say you want to change the sign of one of the things in here, like you want to make this positive. All you have to do is change all the signs, all of them. So if you make this a plus, just make that a minus, okay? And that's it. And you can just do that if there's like, 100 terms here, as long as you change them all, you can do that, okay? All right, we got one more of these guys, okay? And it's fractions, so it's going to look kind of scary, but I promise it's not that bad. So x equals negative 14 over 15, okay? When you have a fraction in front of your variable here, remember again, there's a box around this x, and you can't touch that x. So what you have to do is you have to get the stuff next to x gone. So what you do is you multiply, keep switching markers, you're going to multiply by what's called the reciprocal, okay? Because remember, you can multiply on both sides using the multiplication property of equality, the very first, I guess the only property you learned so far in this video. So what you're going to do is you're going to multiply this left side here by the reciprocal, and the reciprocal is just the opposite of this. You're just going to take this fraction and flip it upside down. So you're multiplying by 9 over 4, okay, which is the reciprocal of 4 over 9. And if you do it on that side, you have to do it to this side as well. So 9 over 4. And the very nice thing again is, remember, the diagonals, as long as the diagonals match like that, they all just cross off, right? That's it. So on this side, you're just left with x. Boom, and that's what we wanted. Now, we do got some math to do on this side. Terrible, right? We got math to do. So, again, now you can just, when you multiply fractions, you can just multiply right across. Negative 14 times 9 divided by 15 times 4. But the numbers are going to be big, and we don't want to work with big numbers. We want to work with small numbers. So the same rule applies. You can reduce these guys diagonally, just they're not going to cross off like that. What's going to happen is you can say, okay, what number can go into 9 and 15 evenly? Well, 3 can. So you say guess I'll do this in red as well. How many times can 3 go into 9? 3 times. How many times can 3 go into 15? 5 times. Okay, so we're reducing the numbers to a lot smaller. Now, for the 14 and the 4, since they're both even numbers, you know 2 can divide into both of them evenly. So how many times can 2 go into 4? 2 times. How many can 2 go into 14? 7 times. And don't forget your negative out here. It's -7. Okay. Now the numbers are way smaller. Okay. So I'll just rewrite what we have. We have -7 over 5 times 3 over 2. Now again, you just multiply it right across. Okay. So -7 times 3 is -21 divided by 5 times 2, which is 10. And that, my friends, is your answer. Okay? So that's the last problem we're going to do with multiplication property equality. Hopefully that made sense. This is the more complicated one we did, just because fractions, no one likes fractions, but unfortunately I have to warn you, they're going to be everywhere. So just do your best to get comfortable with them, really understand fractions, and then you got nothing to be afraid of. It's just like anything else. All right, on to the next guy. All right, so one more property, and I think you guys will like this one. I don't know, maybe I'm wrong. Again, this is called the addition property of equality. So the last one was called multiplication property. This is the addition property equality, okay? And it just says this. It says, if A equals B, then A plus N equals B plus N, and A minus N equals B minus N, okay? So this right here is your property. Again, put that in your notes, okay? Basically what this is saying is if you start with an equation, you know, you can add something on both sides as long as you do it to both sides. If you add something on the left, you have to add it on the right as well. Same thing with subtraction. If you subtract something on the left, you have to subtract the same thing on the right, okay? Now, I'll leave that up there for now. And it's going to make, if that doesn't make sense, again, it's going to make way more sense when you actually see it, okay? So check it out. X plus 2 equals 8. Again, directions are the same thing, solve, okay? What are we solving for? We are solving for x, okay? So remember, x is stationary. We don't want to move that. We want to move the things around x to get x by itself. So if you put your hand over x, what do you see? What's left, okay? You got this 2 here, and it's a positive 2, okay? So how you get rid of a positive 2 is you always do the opposite, okay? So this is plus 2, you're going to minus 2, okay? So minus 2, minus 2. Remember, if you do it on the left, you have to do it on the other side of the equal sign as well. So a plus 2 and a minus 2, you see those cancel off because they're opposites, okay? It's like you had $2 in the bank, you bought something for $2, now you have $0 in the bank. So what are we left with? On this side, we just have an x, which is what we wanted. 8 minus 2 is 6. And that's really all this property of addition here is saying. It's just saying you can subtract something from both sides, or you can add something to both sides, and that's it. And again, you could check it. You just take the 6, plug it back into x. 6 plus 2 is 8, so 8 equals 8, and we're good to go. All right, let's try a few more of these. All right, that guy should be in your notes by now. All right. So now we have 7 equals y minus 3, okay? Put your little variable in a box because we're solving that guy. What's next to your variable on the same side of the equal sign? The -3 here, okay? So what you got to do is the opposite of a -3 is a positive 3. So if you add it here, you got to add it to the other side of the equal sign, okay? So plus 3. These guys cancel because negative 3 and positive 3 are opposites. So on this side, you have y equals 7 plus 3 is 7, 8, 9, 10. Y equals 10. And there you go, okay? So I think you guys are going to be getting this, but let's try another one, okay? Can never have too many examples. Z plus 2 minus 7 equals negative 3, okay? So in this one, the first thing you got to notice is, you see, we got two numbers here. We have a positive 2 and a negative 7. So you can combine those before you do anything else. So we'll just bring our z down. Now what's 2 minus 7? It's going to be negative 5. Okay? 2 minus 7 is negative 5 equals negative 3. Now it's just an equation like all the other ones we've seen. So I'm going to give you guys a second. What do you think we got to do on this guy? If we put z in that little unmovable box, right? What do we do? Give you guys a few seconds. All right. You always do the opposite, so you have to add it. So you plus 5 plus 5. Those guys cancel, and you're left with z equals negative 3 plus 5 is a positive 2. And there you go. All right. We got two more examples, and then we'll wrap this guy up. All right. Whoa. All right. We have dreaded fractions. 3 over 2 equals 4 over 5. Okay. Now, nothing changes because there's fractions. Okay. Nothing changes. So you do the same exact thing. Get your m by itself. So this is a plus 3 over 2. So you're going to have to subtract it. You do the opposite. 3 over 2 minus 3 over 2. Those guys go away. On the left side, we're just left with m equals. Now this guy, what I usually do is I'll just kind of go off to the side and just do it. So we have 4 over 5 minus 3 over 2. So fractions, okay? I have a previous video on fractions. If they don't make sense, you can go get extra practice for that. So with fractions, what you have to do is you have to get a common denominator. In this case, the common denominator is going to be 10 because 5 goes into 10 and 2 also goes into 10, okay? So in order to get the bottom here to be a 10, you have to multiply by 2, but if you do it on the bottom, you have to do it on the top, okay? Now on this side, if we want the bottom to be 10, we have to multiply by 5 and multiply by 5 there as well, okay? Because now both of our denominators here are going to be 10. So, and if that's too quick for you, like I said, go watch the fractions video, it'll make way more sense, okay? So, you just kind of do the math here. 2 times 4 is 8 divided by our 10, minus 3 times 5 is 15 over our 2 times 5 is 10. Now that the bottoms match, okay, once the bottoms match, you just subtract them. So 8 minus 15 is going to be negative 7, and you just carry the bottom here. Once they're both the same, you just keep it the same, okay? So 8 minus 15 is our negative 7 here. And that's it. M equals negative 7 over 10. And again, you can check this, you can check this as well by plugging it into M, doing the math, and they should equal each other, okay? Now, one last problem, but it's more of a note than anything. I just wanted to throw it in here just in case you guys see that anywhere on your homework or, I don't know, wherever you guys happen to run into this guy. So we have 0 equals 100 times x, okay? So nothing changes, the same thing. You're trying to find x. Put the guy in a little box here. All right, so this is multiplication, so you're going to divide the 100 so it'll cancel out, but you got to do that to both sides. So on this side, what are you left with? Just x equals. Now, what's 0 divided by 100? Well, 0 divided by anything is 0. That's the cool thing. That's why I picked 100 here, just to pick some large number, you know, try to freak people out, I don't know. 0 divided by anything is always 0. So x equals 0. Okay? And I guess I should add one more thing. If you ever, for some reason, have 0 on the bottom, the answer would be, it's undefined. Okay? Because you can never, ever, ever divide by 0. So you can never have 0 on the bottom. That's undefined. But if you have 0 on the top, 0 divided by anything is just 0. And that concludes the introduction to linear equations. I'll see you guys in the next video.